Okay, now before I show how to solve this problem, I just want to make a few disclaimers, and one of them is that my asthma is really working pretty hard on me this afternoon, so it may sound odd the way my breathing is. And another thing, my slate's acting up, so I'm going to have to use all my writing. I'm going to have to use my mouse to do all my writing, so hopefully it won't be too messy, and hopefully my breathing will not be too big of a distraction. So this is a problem that my students are going to have to solve in class with their groups. I wanted to solve this problem myself so that it can be used as a model when students are home and doing their homework by themselves. So I'm going to start off by reading the situation, and it's a pretty long, perhaps complicated situation. And after I read it very carefully, I'm going to go back and I'm going to employ the CUBES, C-U-B-E-S method for solving problems. Okay, so it says here that Lance is painting a ceiling that's 10 feet long and 12 feet wide. It has 4 rectangular cutouts for 4 lights that will be installed after the paint has dried. Each cutout is 3.5 feet long and 1 1/4 feet wide. What is the area of the ceiling that Lance is painting? So with our cubes method, the way we use that is we have a C for circling important numbers. We have a U where we underline what we have to do. We have a B where we put boxes around important math operations. And then we have an E to evaluate, which means pretty much solve it. And then we'll evaluate the steps, and S is actually to solve it. So I'm going to circle. I'm going to circle this part right here, 10 feet. I'm also going to circle 12 feet. I'm going to circle 4 rectangular cutouts. And I'm going to circle 4 lights. Those 4 cutouts are going to be for 4 lights. And I'm going to circle each. And I'm going to circle this mixed number. And I'm going to circle this mixed number. Next, I'm going to underline what it is that I ultimately have to do. And here, I have to answer this question here. What is the area of the ceiling that Lance is painting? So that's the question I'm going to have to finally answer. And I'm going to put a box around my important math words that kind of lead to an operation. So I have here area. And with area, I know that I'm going to have to multiply length times width. And I'm not going to put boxes around these because I think area by itself is good enough. I could almost put a box around each because it tells me I'm going to have to find out of the area of these 4 lights that are 3.5 feet long by 1 1/4 feet wide. But I think I'll just leave my box around area. Now, when I'm thinking how to approach solving the problem after I've gone through and done all this, I'm going to use a model. I'm going to create a math model, which is thinking like a mathematician. Number 5, I want to say it's number 5, or maybe it's number 4. The toolkit might be 5, making a model might be number 4. So in any event, I'm going to make this ceiling. So let's say that this is the ceiling, and we'll label it in just a second. 12 feet wide, 10 feet long, and I'm going to go ahead now and put in our 4 rectangular cutouts for the lights. So we're going to have a cutout here, and of course these are not drawn to scale. These are just to kind of help me wrap my mind around, help me visualize what it is that I'm looking for so that I'm able to better solve my problem. Okay, now I'm going to go ahead and put the dimensions. So this, like I said, was 10 feet. And not being able to use my slate sure does make it difficult to write this stuff down. And this is 12 feet. Okay, so this is the dimensions here. So I can go ahead and find the area of the ceiling as if it's one solid piece, and then find the area of just one of these rectangular cutouts. And whatever the area is of just one, because they're all the same dimensions, 1¼ feet by 3½ feet, since they all have the same dimensions, I can put that area here, the area here, the area here, the area here, or I can take that one area for this one, multiply it by 4, and then take that product and subtract it from whatever the area is for this rectangular shape here, and then that will tell me what the area is that he is painting, because he's not going to be painting the cutouts. So let's go ahead and solve now. So I evaluated my steps, and I'm going to go ahead and solve it. So I know that area of a rectangle is going to be area equals length times width. So length. And I like to use a cursive L, because if I just put a 1 here, some kids look at that and think it's just a 1. I mean, if I put an L, just a printed L, they think it's a 1. So I like to put the cursive there. So let's do just one of these cutouts. So I'm going to say area equals, and I know that one cutout is 1¼ by 3½ So 1/4 times, and I'm using a dot. I could put an X, but I'm going to put a dot, 3½ Now, to use the standard algorithm for the multiply and mixed numbers, all I have to do is convert those mixed numbers to improper fractions. So I'll go ahead and do that here. So I know 4 times 1 is 4, plus 1 is 5/4. Let's see, I'm going to use a little dot for the multiplication symbol. 2 times 3 is 6, plus 1 is 7, so 7/2. And now let's see if we can do any kind of cross simplification, and I cannot. 4 and 7, the greatest common factor is 1. They won't cross simplify, and 5 and 2, the greatest common factor is 1. They will not cross simplify. So let's go ahead and just multiply from left to right. So area equals 5 times 7 is 35. 4 times 2 is 8. Now I'm going to convert this improper fraction to a mixed number. So area equals, well, 8 will go, I can get 4 groups of 8 out of 32. I can get 4 groups of 8 out of 35, because 8 times 4 is 32. 35 take away 32 is 3. So I'm going to put 3 here, and I'm going to put an 8. And because this is area, let me put my unit of measure as feet squared, or I could say square feet, either one. So just one cutout is going to be 4 3/8 square feet, or feet squared. Now, if this is 4 3/8 square feet, so is this one, and this one, and this one. So I'll go ahead and multiply this by 4, and then that will give me the amount of area that I need to subtract from the area of the whole ceiling. So let's go ahead and work this problem here. So we'll say area equals, and here's a little trick I'm going to do. I'm not going to bother putting L times W, because I've already illustrated that here. I'm not going to use 4 3/8 times 4. I'm going to use this because I know I'm going to have to make an improper fraction anyhow. So I'm going to say 35/8. Since I'd have to make this an improper fraction anyhow, I'm just going to go ahead and use what I already know. So 35/8 times 4. And instead of just putting 4, I'm going to put 4/1, because I'm going to have to make that whole number an improper fraction too. Now I can cross simplify here. I can say that 4 and 8, the greatest common factor is 4. There's 1 4 and 4, and there are 2 4s in 8. And so now what I have is 35 times 1 equals 35, and then 2 times 1 equals 2. Now let's convert this to an improper, to a mixed number, just to see what we got. But I can about guarantee I'll wind up having to, well, let me just go ahead and do it this way. So I can get, looks like about 17 groups of 2, out of 35 because 17 times 2 is 34. 35 take away 34 is 1. And then my denominator stays 2. Okay, so 17.5 feet squared is the area of all 4 of these. So I've got this area, and this area, and this area. The 4 of them combined, I have represented by this amount here, 17.5 feet squared. Now let's go ahead and finish it up. So now I'm going to go ahead and I'm going to find the area of the whole thing. So just to make it easier on myself, if area is the length times width, I know 12 times 10 is 120. So 120 feet squared is the area of the total ceiling before subtracting the cutouts. So 120 feet squared is the area of the whole thing, but I still have to subtract from it 17.5 feet. 17.5 feet. So let's see if I can find some space to do that. Let's try to do it right here. We'll go ahead and try to do it right here. So I've got 120 subtract 17 and 1/2. Okay, now I'm going to do a little bit of regrouping here. Instead of having 120, I'm going to make this 119. And the one that I borrowed, I'm going to make it 2 over 2. Because 2 over 2 is equal to a whole plus 119 is our 120. And I had to have a fraction with the like denominator to subtract this half here, and so I thought since this is 2 here for my denominator, and I'm going to have a common denominator anyhow, that this would have to be a 2. I just went ahead and made my numerator a 2 for the whole. Now 2 take away 1 is going to be 1, and then the 2 stays the same. And then 119 take away 17, well 9 take away 7 is 2, 1 take away 1 is 0, and then 1 take away nothing is 1. So 102.5 feet square. It is a very long process to get there, but this is our final answer. And I like putting a box over my final answer when I have all kinds of steps here. And my final answer for the question, what is the area of the ceiling that Lance is painting? The area of the ceiling that Lance is painting is 102.5 feet squared. Some of the things I did to help me solve the problem is I made a math model. Also, I used standard algorithms as necessary, like when I had to multiply mixed numbers by mixed numbers, when I had to do some subtraction and things like that, I used standard algorithms. And I could also say that in the beginning I made sense of the problem by coming up with a plan and working it out step by step. And my plan was to make my model and find the area of one cutout, multiply that area by 4 because I had 4 cutouts just alike, and then find the area of the total ceiling, and then subtract the area of the cutouts from the area of the ceiling, and that gave me my final answer. I really like this kind of problem because it makes you think, but it's nothing that we have not mastered by the 6th grade already. It's a lot of steps, and it makes you feel pretty good about yourself that you were able to do all these different steps, do all these operations, and finally get the correct answer. I hope this helps with your homework. Thank you.